Ancient monuments were not just tombs or temples. They were sophisticated cosmic machines. We are rediscovering the solar engineering genius of monument builders, and it rewrites everything we thought we knew about the past. These structures, from the Great Pyramids to remote mountain temples, contain precise astronomical codes locked in stone. By the end of this journey, you will see history's most famous landmarks not as silent ruins, but as dynamic, purposeful engines designed to harness the light of the sun. Why would cultures separated by oceans and all engineer their grandest projects to capture a single beam of light on one specific day? What forgotten science allowed them to achieve such accuracy without any modern tools? How does this hidden legacy change our understanding of human ingenuity? What does it truly mean to build for eternity? That moment of alignment, the sunbeam finding its target, was not a lucky accident. It was a calculated event, engineered into the very bones of the structure. This is the foundational shift in understanding. These monuments were not just built to be seen, they were built to see. They functioned as celestial observatories, permanent fixtures on the landscape designed to track the most important clock humanity has ever known, the sun. For generations, the dominant view saw alignments as symbolic, perhaps a tribute to a sun god. But the evidence points to something far more practical. When the same alignment occurs year after year, century after century, with such precision, we are looking at a tool. Like Clive have spent decades mapping these sites, and the statistical data is compelling. The odds of so many monuments from unrelated cultures accidentally lining up with major solar events are vanishingly small. This was intentional engineering on a grand scale. Consider the necessity behind it. For an ancient farming society, the sun's cycle was the ultimate calendar. Knowing the exact day of the winter solstice, the moment the sun begins its return and the days grow longer, was critical knowledge. It dictated when to plant, when to harvest, when to prepare for the lean months. Survival itself was tied to this solar rhythm, so they built a machine to measure it, a machine made of stone. In Ireland, a 5,000-year-old passage tomb is crowned with a special roof box. For just a few minutes at dawn on the winter solstice, a narrow beam of sunlight travels up the long, dark passageway and illuminates the central chamber deep within the mound. This event is not visible from the outside. It is a private, precise performance of light for the interior space, a clear marker of the year's turning point. Across the Atlantic, at Canyon in the American Southwest, a spiral petroglyph is carved high on a cliff face. For most of the year, it sits in shadow. But on the summer solstice, a dagger of sunlight formed by the gaps between two massive rock slabs pierces the center of the spiral. As the days shorten, the light dagger moves, framing the spiral in different ways until it vanishes, marking the solar standstill. These are not vague gestures. They are specific, repeatable, and breathtakingly accurate. This transforms our view of the architecture. The stones are no longer passive. They are active components in a giant instrument, their positions carefully calibrated to capture a single, fleeting moment of light that speaks of seasons, cycles, and a deep, functional connection to the cosmos. But to move from recognizing a pattern to decoding a blueprint, we need a new vocabulary. The ancient builders spoke in a language of light and stone, and to understand them, we must learn their grammar. This is where archaeoastronomy comes in. It is not merely spotting where the sun rises over a stone. It is a rigorous, interdisciplinary science that blends archaeology with astronomy and ethnography, the study of cultural practices. It gives us the analytical tools to separate coincidence from calculation. One of the most powerful concepts in this field is the horizon calendar. For us, a calendar is a page or a screen, but for an ancient astronomer, the calendar was the skyline itself. They would identify a distinct notch between two hills, a lone peak, or a dip in a distant mountain range. The sun does not rise in the same place every day, it marches along the horizon throughout the year. On the summer solstice, it rises at its farthest point north. On the winter solstice, its farthest point south. By marking where the sun first appeared each day against these permanent horizon features, they created a giant, open-air observatory. The entire landscape became a clock face. Another critical principle is the use of foresights and backsights. Think of it like the sights on a rifle, but scaled up to a monumental level. A backsight is the fixed observation point, often a stone, a platform, or the center of a temple. The foresight is the distant marker, which could be a standing stone, a carved notch, or a natural peak. The builder's genius was in placing these 2 points in exact alignment so that on a specific day from the backsight, you would see the sun or a star appear to rise or set directly over that foresight. This turns a passive view into an active measurement. Consider the vast lines in Peru. For decades, they were seen as mysterious drawings only visible from the air. But researchers and others proposed a different function. They analyzed the long, straight lines that stretch across the desert and found many were aligned with the points on the horizon, where the sun and other celestial bodies would rise or set during important times of the year. These lines may have been ceremonial pathways, guiding people toward these celestial events, integrating the sky directly into ritual movement across the land. This analytical approach also forces us to ask a vital question: are we looking at precise engineering or symbolic alignment? A precise engineering feat implies a deep understanding of mathematics, geometry, and long-term observation, allowing predictions of solar movement for generations. A symbolic alignment might be slightly less accurate but held profound ritual meaning, marking a general sacred time rather than an exact astronomical moment. Both are forms of intentional design, but they speak to different levels of technical knowledge and cultural priority. By applying these principles, we stop simply seeing ancient stones and start reading the instructions left behind. We move from wonder to understanding, which is essential before we can appreciate the true sophistication of the individual machines these cultures built. Stonehenge stands as a testament to this language of light, its stones whispering a message of celestial precision across 4,000 years. This is not a random arrangement of megaliths. It is a carefully engineered instrument focused on the sun's most dramatic turning points. The entire layout of the monument is built upon a solstitial axis, an invisible line that points directly to the midsummer sunrise in one direction and the midwinter sunset in the opposite. If you stand at the exact center of the circle and gaze through the massive arch of the largest, your passes the heel stone and lands precisely where the sun first peaks over the horizon on the longest day of the year. This alignment is the architectural backbone of the entire site, a fact that transforms our perception from a static circle to a dynamic solar marker. The sophistication deepens when we look closer. Recent high-resolution laser scans of the Sarsen stones have uncovered a secret history etched into their surfaces, faint carvings that may represent celestial bodies or mapping patterns, a possible user manual written in stone. The very effort of construction speaks volumes about its importance. The smaller bluestones were transported over 150 miles from the hills in Wales, an unimaginable logistical feat for a prehistoric society. This was not just about finding any stone, it was about bringing specific stones, perhaps believed to hold unique properties, to this specific location to complete this specific celestial machine. Archaeologist Mike Parker's work suggests Stonehenge was the heart of a vast ritual landscape, connected by avenues and processional ways to other sites like walls. This paints a picture of a ceremonial journey tied to the solar cycle, where the community's movements mirrored the sun's own path across the sky, linking the cycles of the heavens with the cycles of human experience. What truly astonishes is the enduring accuracy. The midwinter sunset still frames itself perfectly within the great's grasp, as it has for. This longevity forces us to reconsider the builder's capabilities. Achieving this precision required generations of dedicated observation, a cumulative science passed down and refined. They had to account for the slow wobble in the Earth's axis, a cycle lasting 26,000 years, which minutely shifts the sun's rising and setting points over centuries. The fact that their alignments still hold true today means their understanding was not just observational, it was predictive. They built not for their own lifetime, but for lifetimes uncounted, engineering a perpetual calendar in stone that would continue to mark the seasons long after their names were forgotten. This level of foresight and technical mastery challenges the simplistic view of ancient peoples, revealing them as meticulous astronomers and engineers whose greatest monument was, in essence, a permanent conversation with the sun. While Stonehenge frames the sun's journey on the horizon, the pyramids of Giza capture its essence in a perfect, geometric form. Here in the Egyptian desert, solar engineering was not just a calendar for the living, it was a divine machine for eternity. The Great Pyramid's precision is legendary, its sides aligned to the cardinal directions with an error margin of less than a fraction of a degree. This was not a symbolic gesture, it was a feat of foundational engineering. To achieve this, builders likely used a method called the Indian circle, tracking the shadow of a central rod as the sun moved across the sky, marking the points where the shadow was shortest to find true north. This simple yet brilliant technique transformed the shifting sun into a fixed, directional tool, anchoring their most sacred structure to the cosmos itself. But the solar connection runs far deeper than orientation. The entire Giza complex functioned as a resurrection machine for the pharaoh, powered by sunlight. The mortuary temples attached to each pyramid were carefully positioned. On specific dates, the rising sun would blaze directly down the temple's axis, flooding through the colonnaded halls and into the deepest, darkest inner sanctuary. This was not just illumination, it was a ritual of rebirth. The light of the sun god Ra was seen as a life-giving force, capable of awakening the spirit of the departed king, merging his journey with the sun's eternal cycle of death at dusk and rebirth at dawn. This is where astronomy and theology become one. The so-called air shafts leading from the king's chamber have fueled intense debate. While some theories suggest they aligned with stars like those of Orion's belt, their potential solar functions are equally compelling. On certain days of the year, sunlight could have penetrated these narrow shafts, perhaps to symbolically bathe the chamber in Ra's divine power at a moment of celestial significance. The genius of this system lies in its holistic purpose. Every stone, every angle, every alignment served a dual role, an engineering marvel that also fulfilled a profound spiritual imperative. It was all in service of the fundamental order of the universe, where the pharaoh's eternal well-being guaranteed harmony between earth and sky. The pyramids were more than tombs, they were cosmic batteries, designed to harness and direct celestial energy to sustain order forever. This reveals a different dimension of the ancient mind, where the practical science of aligning tons of stone was inseparable from a sacred duty to maintain the balance of the world itself. High in the Andes presents a different kind of solar genius, one sculpted by the mountains themselves. Here, the Inca engineers faced a unique challenge, a landscape of jagged peaks and steep valleys where the horizon was never a flat line, but a dramatic, uneven silhouette. Their solution was not to flatten the land, but to harmonize with it, weaving their celestial observations directly into the fabric of the mountains. The masterpiece of this approach is a single, exquisitely carved granite pillar whose name translates to the hitching post of the sun. This was no ordinary stone, it was a precision instrument and a profound spiritual anchor. During the equinoxes, when day and night are of equal length, the sun stands directly overhead at noon, and the casts no shadow whatsoever. In that moment of perfect vertical light, the Inca priests performed ceremonies, symbolically tethering the sun god Inti to the earth to ensure his return and the continuation of the seasons. This was the ultimate demonstration of control, not through force, but through precise understanding, a ritual made possible by flawless astronomical alignment. The entire city is a network of such alignments, a stone machine built into the cliffside. The semicircular Temple of the Sun features a trapezoidal window that perfectly frames the rising sun on the June solstice, the shortest day of the year in the southern hemisphere, bathing the interior in a focused beam of light. Other structures align with the anti-zenith sunset, the point where the sun sets directly opposite its zenith passage, a complex solar event critical to the Inca agricultural calendar. But the true brilliance lies in how the builders used the natural world. As researcher John has emphasized, the site's sacred location was chosen not just for its defensibility, but for its relationship to the surrounding apus, the revered mountain peaks. These peaks served as permanent, immovable foresights. By positioning temples and observation points within, the Inca astronomers created to these majestic natural markers, turning the entire Andean horizon into a celestial calendar. A window here, a stone pillar there, all were placed to capture the sun's journey as it rose or set behind specific sacred summits. This reveals a solar engineering philosophy fundamentally different from, say, the geometric perfection of Giza. The goal was integration, not imposition. The architecture does not dominate the landscape, it converses with it. The builders sought to amplify the sacredness already present in the mountains, rivers, and sun, creating a place where the celestial and terrestrial realms were visibly, tangibly connected. Every aligned stone was a testament to a worldview that saw no separation between the cycles of the sky, the rhythms of the earth, and the fate of the empire. The engineering was in service of this harmony, a technical mastery that enabled a spiritual dialogue with the cosmos, ensuring that in this mountain sanctuary, the sun would always be hitched, and the world would remain in balance. The sheer accuracy of these monuments forces a humbling question. How did they do it without lasers or satellites? The answer lies not in lost super technology, but in a profound mastery of simple tools and patient observation. Their toolbox was elegant in its minimalism, built on principles anyone could understand, yet wielded with a precision that still astounds us. At its heart was the Gnomon, a simple vertical stick planted in the ground. This unassuming tool was a powerful solar computer. By tracking the path of its shadow throughout the day and across the seasons, an observer could map the sun's entire journey. The shortest shadow of the day marked solar noon, but the real magic happened over the year. The longest shadow cast at noon signaled the winter solstice, the sun at its lowest point. The shortest noon shadow marked the summer solstice. And the days when the shadow's path traced a perfectly straight east-west line, those were the equinoxes, the moments of balance. With nothing more than a stick, marks in the dirt, and diligent record-keeping, they could define the entire solar year. For establishing cardinal directions, the ancient Egyptians employed the merkhit, a brilliant sighting tool. It consisted of a palm leaf with a slit, mounted on a horizontal bar, used alongside a plumb line. By observing a circumpolar star, one that never sets like our North Star, through the slit and aligning the plumb line, they could find true north with remarkable accuracy. This simple wooden device is why the Great Pyramid's sides are aligned to the cardinal points with an error of less than a fraction of a degree. Geometry on a monumental scale was achieved with rope and pegs. The builders were master surveyors. To create a perfect right angle, they used a knotted rope in a 3-4-5 ratio, a Pythagorean triple known before Pythagoras. Stretching the rope between pegs, with 12 equal segments, they could form a triangle whose largest angle was exactly 90 degrees. To lay out a massive circle, like the foundation of Stonehenge, a central peg and a long rope acted as a giant compass, allowing teams to mark the circumference with perfect consistency. But perhaps their most sophisticated tool was the landscape itself. They used the horizon as a permanent reference grid. By noting where the sun rose each day against a fixed feature, a distinctive mountain peak, or a notch between two hills, they created a living calendar. The sun's rising point migrates north and south along the horizon throughout the year. By memorizing which landmark corresponded to which day, they could read the date directly from the sunrise. This method required no instruments at all, just generations of watchful eyes and an oral tradition sharp enough to preserve the knowledge. This patient, cumulative observation was their true superpower. It was a science built not in a single lifetime, but across centuries, with each generation adding to a growing body of celestial data. Their profound results did not come from complex machinery, but from sustained, focused attention to the rhythms of the natural world. They understood that to master the sky, you first had to learn to truly see it. Yet the question remains, why go to such extraordinary lengths? If a simple gnomon or a horizon marker could tell the time of year, why move mountains of stone? The answer lies in a realm far beyond practical necessity, in the deepest cultural and spiritual imperatives that shaped these civilizations. For them, the sun was never just a ball of fire in the sky. It was a deity, a life-giver, the ultimate source of order in a chaotic universe. Building in alignment with it was not merely an engineering task, it was a sacred act of communion, a way to physically anchor their world to the divine. This transforms our understanding of the monuments. They were not just calendars, they were theaters of cosmic ritual. The architecture made the invisible covenant between heaven and earth visible and tangible. In ancient Egypt, the pharaoh was considered the living son of Ra, the sun god. His power and the kingdom's stability were directly tied to the sun's orderly journey. By constructing pyramids that captured the first light of the solstice dawn, they were performing a perpetual ritual of renewal, using stone to guarantee the sun's return, and by extension, the continuity of the state itself. The monument was a machine for maintaining the fundamental order, and its solar alignment was the proof of its divine function. This idea resonates across the ocean where the worldview was even more participatory. The Maya believed the sun needed human assistance to complete its perilous journey through the underworld each night and rise again at dawn. This help came in the form of ritual, ceremony, and offerings. The architecture was the stage for this vital cooperation. The Pyramid of El becomes a breathtaking symbol of this belief during the equinoxes. As the sun sets, the play of light and shadow creates the illusion of a serpent of light slithering down the northern staircase to join its stone head at the base. This was not a charming optical illusion for tourists. It was the manifestation of the feathered serpent deity closely associated with the sun and rain. In that moment, the building came alive, demonstrating the priest-king's power to summon the god and ensure the cycle of life would continue. The pyramid was a conduit, and the aligned sunlight was the divine presence made manifest. These structures served a powerful political purpose as well. They legitimized the authority of the ruling class. The priest-kings who commissioned these projects positioned themselves as the essential intermediaries between the people and the celestial powers. By controlling the calendar and presiding over the solar rituals within these engineered spaces, they demonstrated a unique, heaven-sent mandate to rule. The common person witnessing the sunbeams strike the altar on the predicted day would see not just a wonder, but a confirmation of the social and cosmic order. This understanding completes the picture. It moves us from seeing cold, precise engineering to feeling the profound human heartbeat behind the stones. The drive to align was a fusion of faith, power, and a deep-seated need to find meaning in the cosmos. These builders were not just tracking the sun, they were conversing with it, building permanent instruments to participate in a dialogue they believed sustained the world itself. The monument was their voice, and the sunlight was the reply. The stones may speak of the sun, but how do we listen with scientific certainty? Distinguishing between a lucky line of sight and a master blueprint is the core challenge of this entire field, and it demands a toolkit far more rigorous than simple observation. We must move from seeing patterns to proving intent, and that journey begins with the mathematics of probability. Like Clive, and apply statistical analysis to these ancient sites, asking a fundamental question: what are the odds? If you take a random point on a landscape and draw a line in any direction, the chance of it pointing precisely to a major solar event like a solstice sunrise is actually quite small. Now, multiply that improbability across dozens, even hundreds of monuments from a single culture. The statistical probability that such a dense concentration of alignments could occur by random chance becomes vanishingly tiny, effectively zero. This numerical evidence forms the bedrock of the argument, transforming intriguing coincidence into demonstrable design. But numbers alone are not enough. We need the human story behind the stones. This is where ethnography, the study of living cultures, becomes invaluable. By examining the myths, oral histories, and ceremonial practices of descendant peoples, researchers find echoes of the builders' original intent. The Hopi and other peoples of the American Southwest, for instance, maintain detailed knowledge of horizon calendars and solar markers that align perfectly with ancient sites like those in Canyon. Their winter solstice ceremonies, which mark the sun's return, provide a living cultural context for the stone circles and petroglyphs their ancestors left behind. These are not vague connections, they are direct threads of understanding, passed down across generations, that illuminate the purpose of the architecture. When a modern ritual aligns with an ancient solstice marker, it strongly suggests that the marker was built for that exact ritual centuries ago. The case strengthens further through repetition and consistency. A single aligned temple might be an anomaly, but a pattern across an entire civilization is a policy. Look at the Maya world. From in Honduras to their cities and pyramids repeatedly exhibit orientations to the sun's path, particularly to the solar zenith passages when the sun stands directly overhead. This was not a one-off architectural whim, it was a systematic cultural principle, a shared sacred geometry applied across their empire. When you see the same sophisticated alignment repeated in different cities, built by different kings over centuries, you are looking at a cornerstone of their belief system, engineered into the heart of every major community. Perhaps the most compelling proof, however, lies in the sheer, gratuitous effort of the architecture itself. Consider the Passage tomb at. Its builders did not merely cap a tunnel with a stone, they engineered a roof box, a specially constructed aperture above the entrance, and then angled the entire 60-foot-long passage with precise corbelled stones, so that a single, narrow beam of dawn light would travel its entire length to reach the central chamber only on the days around the winter solstice. This is not a feature that emerges from basic construction needs. It is an extravagance of design, a complex solution to a very specific, structural problem, letting in one particular ray of light on one particular morning. The difficulty of this feat screams intentionality. It is a deliberate, labor-intensive act to capture a celestial moment. This rigorous scrutiny naturally involves separating solid evidence from speculative noise. The field of ancient mysteries attracts many fringe theories, from claims of alien intervention to lost super-civilizations with laser technology. Responsible archaeoastronomy debunks these not by dismissing curiosity, but by applying razor, the principle that the simplest explanation with the evidence is usually correct. The simplest explanation is not that unknown beings with advanced tech built these sites, but that highly intelligent, observant human cultures, using simple tools and generations of accumulated knowledge, achieved these wonders through patience, skill, and a deep, driving cultural need. This scientific rigor, this commitment to evidence over fantasy, is what elevates the rediscovery of this solar genius from the realm of speculation into a legitimate, awe-inspiring chapter in the story of human ingenuity. It allows us to replace wonder with understanding, and in doing so, appreciate the true scale of their achievement. The most profound test of their knowledge may be written in the sky itself, in a slow, celestial drift almost too gradual for a single lifetime to perceive. Earth's axis wobbles like a spinning top, completing one full cycle every 26,000 years. This is axial precession, and it causes the position of the sun at the solstices to creep minutely along the horizon over centuries. A monument aligned perfectly with the solstice sunrise 3,000 years ago would not be in perfect alignment today. This presents a fascinating archaeological puzzle. Were these builders simply marking the sun as they saw it in their own era, or did they understand and account for this grand, cosmic clock? The stones themselves hold the answer, and it is a subtle one. Take Stonehenge. Its alignment to the midsummer sunrise is still visually powerful, a breathtaking spectacle. But modern astronomical calculations show a slight discrepancy. The sun now rises just a fraction to the left of the heel stone's original. This tells us something crucial. The builders likely aligned it with the solstice sun as it appeared in their own time, around 2500 BCE. They were capturing a moment, not trying to predict its slow migration across. This points toward a ceremonial and observational genius, rooted in the present reality of their skies. Yet this is where the mystery deepens. Some researchers point to a different kind of evidence, not in stone, but in story. The controversial authorgram, among others, suggests that ancient myths from around the world describing great cycles of time, world ages ending in flood or fire, might be cultural memories encoding knowledge of precession. The idea is that an incredibly long-term astronomical observation, perhaps spanning thousands of years, was passed down as allegory. The Maya, for instance, calculated cycles of time so vast they dwarf human history, and their long-count calendar hints at an awareness of larger cosmic rhythms. Could fragments of an older, lost tradition of sky watching have survived in these narratives? Mainstream archaeology remains deeply skeptical of such claims, often attributing the formal discovery of precession to the Greek astronomer Hipparchus in the 2nd century BCE. The prevailing view is that most ancient cultures operated within a ceremonial, aligning their monuments to the sun of their day for immediate ritual and calendrical purposes. Their goal was likely not to build a perpetual machine unaffected by celestial drift, but to create a perfect machine for their own moment in the great cycle. This distinction is vital. It shifts our perspective from looking for impossible foresight to appreciating profound presence. They were not necessarily engineers of the distant future, but exquisite observers of their present cosmos. The slight misalignments we measure today are not errors. They are chronological markers, fingerprints of the exact century in which the builders stood and watched the sky. They tell us that the sacred moment they sought to eternalize in stone was the one they themselves witnessed, a beam of light specific to their generation, their faith, and their understanding of the world. This realization does not diminish their achievement, it humanizes it. It suggests their genius was in perfect alignment with their own time, both literally and culturally, using the eternal language of astronomy to speak to the urgent needs of their own age. This quest for specificity finds its ultimate expression on a sun-baked island in the Mediterranean. On Malta, the temple complex, built over 1,000 years before the Great Pyramid, presents a case study in solar engineering of almost microscopic precision. Here, the builders were not content with a general alignment. They engineered a beam of light to perform a specific dance on a specific stone, on 2 specific days of the year. The lower temple's main doorway is a masterpiece of celestial targeting. On the mornings of the spring and autumn equinoxes, when day and night are of equal length, the first rays of the rising sun pass directly through this entrance. They travel down a short corridor and strike a central stone slab deep within the temple's heart. But the architects did not stop there. They incorporated a brilliant optical feature. 2 large stone slabs flanking the corridor are positioned to act like a giant camera, creating a pinhole effect. This does not simply flood the chamber with light, it projects a distinct, sharp rectangle of sunlight onto the back wall. As the sun rises, this rectangle of light moves in a deliberate path across specially marked stones. It is a calibrated light show, a silent, stone clock marking the moment of celestial balance. Archaeologist Frank Ventura, who has studied these temples for decades, argues this was no accident. The entire complex functioned as a sophisticated agricultural and ritual calendar for a society that built these structures centuries before the wheel was in common use. The precision is breathtaking. The equinoctial alignment is so exact that on the days immediately before and after, the sunbeam misses its target entirely. This tells us the builders possessed not just observational skill, but the geometric and architectural prowess to translate that observation into a permanent, functioning instrument. For a temple-building culture obsessed with cycles of life, death, and renewal, as evidenced by their art and the design of their sacred spaces, this equinoctial event would have held profound meaning. The equal day and night symbolized a moment of perfect equilibrium in the cosmos, a time to perform ceremonies ensuring fertility, balance, and the continuation of the community. The moving rectangle of light provided a visual countdown to that sacred instant, transforming the temple from a static building into a dynamic participant in the ritual. The temples strip away any remaining doubt about intent. This is not a monument vaguely facing the sunrise. It is a machine built to capture and display a single, razor-thin slice of solar time. It demonstrates that solar engineering could achieve a level of specificity we might associate with modern instruments, all in service of connecting the rhythms of a small island society to the grand, dependable pulse of the heavens. The precision of these solar machines points to a deeper layer of understanding, one written not just in light, but in number and form. The stone circles and pyramids are not random piles of rock. They are embodiments of mathematical principles, a sacred geometry that may have encoded the very laws of the cosmos they sought to honor. This is where the physical engineering meets a more abstract, yet equally deliberate, form of design. The builders often employed whole number ratios in their dimensions, proportions that resonate with fundamental mathematical constants. A famous example is found in the Great Pyramid. If you take the pyramid's perimeter and divide it by twice its height, the result is a number remarkably close to pi, the ratio of a circle's circumference to its diameter. This was not a coincidence of random measurement. It suggests the designers intentionally incorporated this ratio into their grand plan, perhaps symbolizing the squaring of the circle, a fusion of earthly and celestial perfection. Across the sea at Stonehenge, the geometry of the Sarsen circle reveals another layer. The arrangement of the massive uprights and lintels may reflect the use of Pythagorean triangles, right-angled triangles with specific side ratios, centuries before the Greek philosopher gave them his name. Researcher John proposed that such geometries were not merely structural, they represented a cosmic blueprint. He argued this was a sacred language of number, a system where the microcosm of the temple mirrored the macrocosm of the heavens. The specific triangles and ratios used may have served a dual purpose, providing structural stability while also functioning as a predictive model for complex celestial events, like the subtle wobbles of the moon's orbit over its long cycle. This idea of a cosmic geometry transforms our view of these sites. They become three-dimensional equations, stone expressions of a belief that the universe itself was built on harmonic, mathematical principles. To build in alignment with those principles was to tap into the foundational order of creation. The question that naturally arises is one of intent. Were these ancient architects consciously applying mathematical constants like pi or the golden ratio as we understand them today? Or did these proportions emerge naturally through an iterative design process, a trial and error refinement of forms that were simply pleasing to the eye and stable to build? Scholars debate this vigorously. Some see the hand of a lost, advanced mathematical tradition. Others suggest that repeated practical experience, like rolling a cylindrical stone to measure distance, could intuitively lead to an approximation of pi without formal theory. Yet even if the latter is true, the consistent presence of these elegant ratios across cultures and continents suggests something profound. It reveals a shared intuitive grasp of harmony and proportion, a sense that certain shapes and numbers held inherent power and correctness. This points to a worldview where number, physical form, and celestial motion were seen as threads of the same tapestry. The engineering mindset was not separate from the spiritual one, it was its practical expression. To calculate the angle of a pyramid face was a devotional act. To lay out a stone circle using a rope in a perfect Pythagorean triangle was to participate in the geometry of the universe itself. This fusion is perhaps their greatest legacy, a reminder that in seeking to understand the sky, they first had to master the silent, perfect language of mathematics etched into the very stones beneath their feet. But how did a vision in the sky become a mountain of stone on the ground? The journey from celestial observation to finished monument is a story of its own, a testament to a kind of genius that blends astronomy with immense practical skill. To understand it, we can reconstruct the steps a master builder might have followed, a workflow that reveals the true scope of their ambition. It always began with the land. A site was chosen not for convenience, but for sacred geography, a place where the horizon was clear and the connection to the cosmos felt strong. Once the location was, the real work of translation started. A team of observers would plant a simple gnomon, a vertical stake, and for an entire year or more, they would meticulously track its shadow. They would mark the ground with smaller stakes or stones where the tip of the shadow fell at noon each day. Over the seasons, these marks would trace a pattern, with the two farthest points representing the solstices and the central line marking the equinoxes. This simple, patient act created a solar map on the Earth itself. Simultaneously, they would note where the sun rose and set against the distant horizon, perhaps tying a cord between two posts to permanently mark a solstice sunrise. The sky's movements were now anchored to the dirt. With the celestial coordinates established, the next phase was geometry. Using long ropes knotted at precise intervals and wooden pegs, the surveyors would transfer these angles into a ground plan. To create a perfect right angle for a pyramid's corner, they might use a rope in a 3-4-5 ratio. To lay out the vast circle of a henge, a central peg and a long rope became a giant compass. Every measurement was a physical act, a stretch of hemp and a driven stake, turning abstract solar angles into the literal footprint of a monument. This was the blueprint, not on parchment, but etched directly into the landscape. Then came the Herculean task of moving the stones. For the megaliths of Stonehenge or the blocks of Giza, this was a symphony of logistics and physics. The builders used what they had, nature and ingenuity. They likely employed wooden rollers, greased with animal fat, beneath massive sledges. They used levers and pivots to inch stones upward onto earthen ramps. Water might be poured on sand to reduce friction for a sledge. This was not magic. It was the applied science of mechanics, understood through experience and guided by the sheer force of coordinated human labor. Hundreds, perhaps thousands, of people would pull on ropes in unison, directed by rhythm and command, moving mountains one agonizing inch at a time across miles of countryside. The final, most delicate act was the raising and orientation. Imagine the moment a ton lintel was poised to be set atop two uprights. This was not merely a construction milestone, it was a ritual culmination. It is highly plausible that the final placement was timed for a significant solar event. As the sun rose on a solstice dawn, its rays would have provided the ultimate guide. Builders could make minute adjustments, turning the stone until its shadow fell exactly along a pre-marked line, or until the sun itself flashed between two reference points. In that moment, the celestial observation that began years before was locked permanently into place. The sun itself became the final tool in the assembly. This entire workflow, from year-long sky watching to the communal heave of the last stone, demonstrates a form of genius we recognize today: project management. It required a visionary who could hold a generational plan, organizers who could marshal and sustain a workforce, engineers who could solve unforeseen problems, and a culture that believed the result was worth a lifetime of toil. It was a coordination of natural knowledge, human labor, and monumental ambition on a scale that still humbles us. They did not just build with stone, they built with time, patience, and a profound faith that their work would speak to the sun for eternity. This living chain of expertise raises a fascinating question: how do you teach a cathedral of stone? In a world without textbooks or blueprints, the transmission of such precise knowledge was a cultural masterpiece in itself, a blend of memory, ritual, and hands-on mentorship. The master builders were not just architects, they were the librarians of a living science, and their method of preservation was as sophisticated as the monuments they left behind. In pre-literate or partially literate societies, the primary vessel for this knowledge was the robust oral tradition. Complex astronomical data and engineering principles were not written down. They were woven into the fabric of daily and ceremonial life. They were encoded in myths that explained the journey of the sun god, in songs that marked the seasons with specific melodies, and in star lore that connected constellations to stories of ancestors and heroes. This made the information sacred, memorable, and integral to cultural identity. A child learning the epic tale of a hero battling the darkness was also, on another level, learning a metaphor for the winter solstice and the sun's return. The ritual calendar itself was a teaching tool, its repeated ceremonies reinforcing the timing of celestial events through experience, not just instruction. This was knowledge felt in the bones, recalled with the rhythm of a chant and the communal anticipation of a sunrise ceremony. Alongside this cultural immersion was the rigorous system of apprenticeship. A young initiate would not simply be handed a chisel, he would be brought into a lifelong partnership with the sky. His training began with observation, spending nights charting star paths and dawns, marking the sun's creeping progress along the horizon. He learned to feel the subtle shift in the air that preceded a solstice, to recognize the quality of light at an equinox. This empirical education was coupled with practical mastery, dressing stone, understanding leverage, and mastering the geometry of ropes and pegs. The master was teaching a holistic craft, where the angle of a pyramid's slope was inseparable from the angle of the sun's rays on a specific sacred day. This created a seamless continuity. The consistency we see at a site like Stonehenge, where the basic solstitial alignment was respected and enhanced over more than 1,000 years of construction and modification, is the direct result of this successful transmission. It was not a static set of rules, but a living tradition that could adapt and refine itself across generations, all while holding true to its core celestial principles. This mode of learning, so different from our own, reveals a profound truth about their genius. Their knowledge was not stored on a shelf, it was carried in people, performed in ritual, and tested with every new stone laid. It was a knowledge that required participation, ensuring that the understanding of the cosmos remained vibrant, relevant, and breathtakingly accurate for century after century. The same architectural solution emerged on opposite sides of the world, built by people who never met. From the damp moors of Britain to the deserts of Egypt and the mountain peaks of Peru, societies with no conceivable contact all directed their greatest efforts toward capturing the same celestial moments. This is not a story of a single genius culture, but of a recurring human impulse, a pattern of thought etched into the landscape of our collective past. The parallels are too specific to ignore. Each of these cultures independently identified the solstices and equinoxes as the most critical points in the solar year. They did not just note them in passing, they monumentalized them, embedding these alignments into the very heart of their most sacred architecture. Whether it was the stone circle on Salisbury Plain, the pyramid on the Giza Plateau, or the temple in the Andean clouds, the most important communal structure was also a precise solar instrument. Furthermore, they all utilized the same basic toolkit, the horizon calendar. They looked to the distant skyline, using natural features or constructed markers as fixed reference points against which to track the sun's migrating path. This was not a technology that could be traded along Silk roads. It was a methodology born from looking up and paying profound attention. The gods, they bore different names: Ra, Inti, an unnamed sun deity of the megalith builders, and the rituals performed in those aligned spaces were unique to each culture's beliefs. Yet the foundational act, The physical engineering of a connection between their place of worship and the solar cycle was strikingly identical. This presents us with a compelling puzzle. Are we seeing evidence of a shared, innate human response to the sun, a kind of celestial intuition hardwired into our species as we transitioned from nomadic life to settled, agricultural societies? Or do these widespread similarities hint at something more elusive, fragments of a common, ancient knowledge that somehow spread across the globe in the deep mists of prehistory, later adapted by isolated cultures? The prevailing scientific view leans strongly toward the first explanation, a process known as convergent cultural evolution. Just as wings evolved independently in birds, bats, and insects to solve the problem of flight, the architectural alignment to the sun evolved independently in separate cultures to solve a universal human problem: how to track time, ensure agricultural success, and legitimize spiritual and political authority. When your survival depends on the seasons, and the sun is the ultimate regulator of those seasons, focusing your greatest communal effort on understanding it becomes a logical, even inevitable, step. The sun was the one constant, the most powerful and predictable force in their universe. It makes profound sense that societies reaching a certain level of complexity would, on their own, arrive at the same brilliant conclusion to build a machine that could speak its language. This independent convergence does not diminish their individual achievements, it amplifies them. It tells us that the drive to seek order in the cosmos, to mark our place within its cycles, and to express that understanding through monumental art and engineering might be a fundamental part of what it means to build a civilization. The stones of Giza, Stonehenge, are not copies of each other. They are separate answers to the same eternal question, each crafted in the unique voice of its culture, yet all harmonizing with the same celestial rhythm. The rediscovery of this ancient solar science is a modern intellectual adventure in its own right. For centuries, the monuments stood silent, their celestial purpose obscured by time and shifting interpretations. It took a new breed of visionary, willing to challenge established views, to learn how to listen to the stones again. One of the earliest pioneers was Sir Norman Lockyer, a British astronomer in the early 1900s. While his colleagues in archaeology focused on artifacts and burial practices, Lockyer looked up. He proposed that Stonehenge and several Egyptian temples were deliberately aligned with the sun and stars. To the academic establishment of his day, this seemed like fringe speculation, an imposition of modern scientific thinking onto ancient ritual. Lockyer faced considerable skepticism, but he had planted a crucial seed, suggesting that the sky was an integral part of the architectural plan. The field truly began to coalesce in the 1960s and 70s, driven by figures who brought new tools and mathematical rigor to the question. Hawkins, an astronomer, used an early IBM computer to analyze the positions of the stones at Stonehenge. His controversial book, Stonehenge Decoded, argued the site functioned as a sophisticated astronomical computer, capable of predicting eclipses. While some of his specific claims were later debated, his work was revolutionary because it applied hard data and statistical analysis, forcing archaeologists to engage with astronomical possibilities on a technical level. Around the same time, a Scottish engineer named Alexander undertook a monumental survey of his own. He personally measured hundreds of stone circles and standing stones across Britain and France. His meticulous fieldwork revealed consistent use of a standard unit of measurement, which he called the megalithic yard, and repeated geometric patterns. He argued these sites were precise observatories, built by skilled surveyors with an advanced understanding of geometry and the lunar cycle. His engineering perspective provided a practical blueprint for how such feats could have been accomplished, grounding the ideas in the reality of construction. These pioneers operated at the edges of their disciplines, and their theories sparked intense, sometimes acrimonious, debate. The archaeological community was rightly cautious, wary of oversimplifying complex sites with single-purpose astronomical explanations. Yet the force of their evidence, the mathematical patterns and repeated alignments, was too compelling to ignore. Their collective work, however controversial in its details, achieved a vital goal. It forced academia to take the celestial connection seriously. Archaeoastronomy gradually earned its place as a legitimate interdisciplinary science, a necessary bridge between the study of human culture and the objective mechanics of the cosmos. Today, the investigation continues with tools Locker or could scarcely have imagined. Researchers and at the Polytechnic University of Milan employ three-dimensional digital modeling, satellite imagery, and advanced software to simulate ancient skies with pinpoint accuracy. They can remove modern visual clutter, reconstruct eroded horizons, and calculate alignments to a degree of precision that settles old debates and reveals new subtleties. This technological leap allows them to ask more nuanced questions, not just if an alignment exists, but how it would have been experienced by a person standing in that specific spot, at that specific moment in history, under the specific cultural beliefs of the time. This modern journey of discovery beautifully mirrors the ancient one. It is a story that begins with simple, patient observation, moves to the formation of a bold hypothesis, and progresses through rigorous testing and measurement. It is about learning to see the familiar landscape with new eyes, to perceive the intentional lines connecting earth and sky. The pioneers of archaeoastronomy taught us that the past still holds profound secrets, not hidden in treasure chambers, but written in sunlight and shadow, waiting for those who know how to look up and ask the right questions. The line between rediscovery and fantasy is often blurred by the very awe these monuments inspire. As we uncover their true sophistication, we inevitably encounter more sensational explanations that attempt to fill the gaps in our understanding. Popular culture loves the idea of a lost super-civilization, a single, advanced source like Atlantis seeding knowledge across the globe. An even more pervasive myth suggests these sites could only have been built with extraterrestrial help, that ancient humans were incapable of such feats on their own. These narratives are compelling in their simplicity, but they commit a profound disservice to the past. They strip the actual builders of their rightful legacy, replacing human genius with an X from the stars or the sea. The truth, while requiring more patience to appreciate, is far more remarkable. Every tool needed to achieve these alignments has been found at excavation sites or documented in living traditions, from stone mauls and copper chisels to knotted ropes and wooden sighting devices. There is no need for alien lasers when a simple gnomon and a patient observer can map the solar year. There is no requirement for anti-gravity machines when we have ample evidence of sledges, rollers, levers, and the coordinated power of thousands of dedicated people. The evidence for the human hand is everywhere, in the quarry marks left on unfinished blocks, in the pottery shards and tool kits found in worker camps, in the gradual stylistic evolution of the architecture itself across centuries. To invoke outside forces is to ignore the mountain of archaeological data that speaks to local, incremental, brilliant human development. Another common layer of myth involves attributing esoteric powers to these sites, suggesting they were built on global energy grids or mysterious vortices. While the emotional and spiritual power of these places is undeniable, claims of measurable, unknown energies or geometric lines connecting every ancient monument on Earth typically lack any archaeological or scientific foundation. They often rely on selective data, ignoring the thousands of monuments that do not fit the proposed pattern, or they impose modern spiritual concepts onto cultures that held very different worldviews. This kind of speculation, while often well-intentioned, ultimately distracts from the tangible genius we can actually study and prove. The real magic is not in a hidden force field, but in the demonstrated ability to move a 50-ton stone 20 miles, to calculate an angle to within a fraction of a degree using a shadow and a string, and to maintain that knowledge across generations through oral tradition and ritual. By focusing on the physical evidence, the alignments, the tool marks, the ethnographic records of descendant peoples, and the painstaking statistical analysis, we build a case that is both more rigorous and more respectful. We honor these cultures by taking their work seriously, by assuming they were intelligent, observant, and fully capable of the wonders they left behind. Debunking these pervasive myths is not an act of diminishing wonder. It is the exact opposite. It is about redirecting our awe toward the authentic story, a narrative of sustained human curiosity, cooperative effort, and intellectual triumph that unfolded right here on our own planet. This story requires no aliens, no sunken continents, just the incredible potential of the human mind when focused on a problem across generations. That, in the end, is the most inspiring mystery of all. Their precision was born in a world of perfect clarity. We must envision the skies they saw, not as we see them now through a haze of electric glow and particulate pollution, but as a deep, black canvas where every star was a sharp pinprick of light, and the sun's first gleam was a razor's edge on the horizon. This pristine visibility was not a poetic backdrop. It was a fundamental tool, as essential as their ropes and stones. Without the constant wash of artificial light, the subtle gradations of dawn and dusk were pronounced, allowing them to mark the exact moment the sun's limb broke the horizon with astonishing accuracy. The air itself was likely cleaner, with less atmospheric dust to scatter and soften the light, making celestial movements appear crisp and definitive. Their entire science depended on this environmental gift, a transparency we have largely lost, which allowed them to see the cosmos with a naked-eye clarity we can scarcely replicate. Equally vital was the stability of their horizons. For a society using the skyline as a calendar, the landscape itself had to be a reliable reference. The builders of Stonehenge worked on the expansive Salisbury Plain, a relatively flat expanse where the horizon was a clean, distant line. A shift of a single sun's width along that unbroken edge was a clear, measurable event. In the Andes, the horizon was not flat but spectacularly jagged, yet it was permanently fixed. The peaks and notches of the surrounding mountains were immutable markers, far more stable than any human-built stone could ever be. This partnership with a static landscape was genius. They outsourced the permanence of their observatory to geology itself. Climatic windows also played a role. The Neolithic, a period of significantly wetter conditions in what is now the Sahara Desert, created a greener, more hospitable environment. This era coincides with the early pastoral cultures that preceded dynastic Egypt. While not directly building the pyramids, this favorable climate may have supported larger, more stable populations capable of developing the complex social organization and sustained observation traditions that later culminated in Giza's solar engineering. This environmental context reframes their achievement. It was not a triumph over nature, but a profound collaboration with it. They did not conquer their landscape, they listened to it. They identified the most stable, prominent features on their local horizon and used them as the fixed sites on their colossal surveying instrument. The unchanging mountain peak, the distant river bend, the lone hill on a plain, these became the anchors of their cosmic clock. Their genius lay in recognizing these natural endowments and designing their architecture to engage in a permanent dialogue with them. The monument was the moving part, the human-made component carefully calibrated to interact with the sun's journey across a backdrop that had been set by nature before they arrived. This deep environmental integration means their precise alignments are not just feats of engineering, but also acts of profound geographical literacy, a testament to seeing the land not just as a place to build, but as the essential partner in a conversation with the sky. This cosmic blueprint demanded a civilization in motion. To translate a vision of the heavens into a mountain of stone required more than brilliant astronomers. It required the unified effort of an entire society, a collective endeavor on a scale we can barely comprehend. This was arguably the most complex social project of the ancient world, a logistical ballet that could only succeed with profound organization and a shared, compelling purpose. First, the basic needs had to be met. Feeding, housing, and sustaining a workforce of hundreds, perhaps thousands, over years or even decades was a monumental task in itself. This implies a society with a stable agricultural surplus, skilled administrators to manage supplies, and a social structure capable of mobilizing people not as slaves under a whip, but as participants in a sacred mission. The evidence from worker villages near the Giza plateau, for instance, shows bakeries, breweries, and medical facilities, suggesting a degree of care and organization that points to a coordinated national effort, not coerced labor. The driving force behind this mobilization was almost certainly a powerful spiritual or royal authority, a leader or priestly class capable of articulating a cosmic vision so compelling it motivated generations. They framed the construction not as mere work, but as a divine duty, a necessary act to ensure the sun would rise, the seasons would turn, and the cosmic order would hold. By promising to build a machine that would secure the favor of the gods for everyone, they transformed backbreaking labor into a sacred pilgrimage. The monument, once completed, then served to permanently cement that social order. Its sheer scale and impossible precision visually demonstrated the elite's unique, heaven-sent connection. When the common person witnessed the sunbeam strike the altar exactly as the priests had foretold, it was not just a celestial event, it was a performance of power, a live demonstration that the rulers could indeed commune with the forces that governed life itself. This legitimized their authority in the most profound way possible. Yet the process itself was just as transformative as the final product. The communal act of construction, synchronized with the celestial cycles, forged a powerful shared identity. Imagine the rhythm of the work, the hauling of stones in time with the seasons, the raising of a lintel perhaps timed to a solstice sunrise. This created a deep, lived connection between the people, their labor, and the cosmos. They were not just building a temple, they were physically weaving their community into the fabric of the universe. The project became a story they told with their hands, a narrative of collective purpose that defined who they were. In this light, solar engineering emerges as the ultimate social glue. It was a technical feat that served a profound social function, coordinating human energy toward a goal that transcended any single lifetime. It defined a civilization's relationship with time, not as fleeting days, but as eternal cycles they could capture in stone. It structured their relationship with authority, rooted in a perceived celestial mandate, and their relationship with the divine, making it visible, predictable, and embedded in the very center of their world. The legacy they left was not just in the aligned stones that outlasted empires, but in the model they provided, a testament to what human society can achieve when united by a vision that reaches for the stars. The echo of that ancient impulse to build with the sun did not fade with the last stone circle or temple. It simply changed its form, resurfacing in our modern world in ways that bridge of thought. Today, architects and artists consciously reach for the same principles that guided the builders of Giza and Stonehenge, not for ritual, but for resonance and reason. The drive to align human creation with a cosmic order is alive and well, expressed now through the lenses of sustainability and profound art. Consider the work of architects like Norman Foster and his firm. They champion a philosophy of high-tech environmental design, where buildings are meticulously oriented to the path of the sun. This is not just about adding solar panels as an afterthought. It is about designing the entire structure from the ground up to work with solar geometry. The building's shape, the depth of its overhangs, the placement of its windows, all are calculated to maximize natural light and heat in the winter, while providing cooling shade in the summer. This is passive solar design, a sophisticated, energy-efficient application of the same fundamental wisdom the ancients used, turning architecture into a machine that harnesses sunlight for human comfort and sustainability. Here, the celestial alignment serves a practical, earthly purpose, reducing reliance on artificial systems by engaging in an intelligent dialogue with the sun's eternal cycle. It is ancient solar engineering reborn through the science of thermodynamics and computer modeling, proving that this knowledge is not obsolete, but profoundly relevant. Parallel to this practical revival is a movement in the world of art that seeks a more philosophical and experiential connection. In the 1970s, the land art movement saw artists leaving galleries to create monumental works directly in the landscape, often engaging with cosmic themes. Artist Nancy Holt created one of the most direct modern homages to ancient sky watching with her work, Sun Tunnels, installed in the remote Utah desert. The piece consists of 4 massive concrete pipes, each aligned to frame the rising and setting sun on the solstices. The tunnels are also pierced with holes that correspond to the constellations of Draco, Perseus, Columba, and Capricorn, allowing star patterns to be projected inside at night. Holt did not call it an observatory, but a viewing chamber that makes the celestial cycles tangible. Her work has no practical function in the modern sense. It does not heat a building or tell farmers when to plant. Its purpose is perceptual and poetic, to slow us down and reorient our sense of time and place within the vastness of the cosmos. In creating it, she explicitly connected her process to that of ancient cultures, stating she wanted to bring the vast cycles of the sun and stars down to a human scale. Sun Tunnels is a conscious, artistic resurrection of the megalithic mindset, using modern materials to stage the same celestial performance that captivated our ancestors. These two threads, the architect's sustainable pragmatism and the artist's poetic inquiry, are different expressions of the same enduring human desire. They demonstrate that the impulse to mark our place within the cosmic cycle was never truly lost. It evolved. It moved from a communal, survival-based imperative to an individual or societal choice, one that now speaks to our need for ecological harmony and personal meaning. The modern solar-aligned building seeks to minimize our footprint on the Earth by working with its greatest source of energy. The modern land art installation seeks to expand our perception, to remind us of our small but conscious place in a grand universe. Both are acts of alignment, both are conversations with the light. This living legacy creates a direct, unbroken line from the anonymous stone masons of prehistory to the designers and visionaries of today. It suggests that the fundamental goal of those ancient builders, to forge a visible, tangible link between human endeavor and celestial order, still resonates at the deepest level of our creativity. We may no longer believe the sun needs our help to rise, but we still feel the profound need to build in a way that acknowledges its journey, to create structures that honor the rhythm of light and shadow, and to find our own meaning in the endless turn of the seasons. The language has changed, but the conversation with the sky continues. This ongoing rediscovery is accelerating, fueled by tools that would have seemed like magic to the builders themselves. Light detection and ranging, or LiDAR, is perhaps the most revolutionary. By firing laser pulses from an aircraft through dense jungle canopy, this technology strips away the vegetation to map the ground beneath with centimeter precision. In places like the Guatemalan rainforest, LiDAR has revealed vast, interconnected networks of Maya cities, causeways, and ceremonial complexes previously invisible to ground surveys. Within these newly discovered urban grids, researchers are now identifying potential plazas, temple platforms, and elongated structures that may hold fresh solar or celestial alignments, waiting to be decoded. It is like being handed a complete, unknown city map where every street might point to a forgotten star. Alongside this, drone photography provides an agile new perspective. Where a researcher once had to climb a precarious cliff or rely on a single ground-based photograph, A drone can now capture hundreds of high-resolution images from every angle, constructing precise three-dimensional models of entire sites. This allows for virtual exploration, measuring and testing alignment hypotheses from any vantage point without ever disturbing the stones. The most profound tool, however, may be the software that can wind back the cosmic clock. Advanced astronomical simulation programs can now reconstruct the precise appearance of the night sky for any location on Earth, on any date in the past, accounting for the slow drift of axial precession. This lets researchers ask incredibly specific questions. Did this window frame not just the summer solstice sunrise, but the rising of the star Sirius 2,000 years before the Common Era? Could that corridor have been designed to capture the light of Venus at its evening apparition? We can test these theories with a few keystrokes, moving from speculation to simulation. Yet for all this technological power, profound mysteries persist. We have strong evidence for their mastery of the solar cycle, but what of the more complex planetary dances? To what extent did they track the 8-year cycle of Venus, so important to the Maya, or the 29.5-year orbit of Saturn? Did they perceive a grand, unified celestial mechanics, a theory connecting the sun, moon, and wandering planets into a single, harmonious system expressed through their architecture? The answers may lie in subtler alignments we are only beginning to search for. Future research will likely delve into the moon's 18.6-year cycle, the major lunar standstill, where the moon rises and sets at its most extreme northerly and southerly points on the horizon. This is a far more complex pattern than the sun's annual journey, and evidence for its observation would indicate a truly long-term, sophisticated astronomical tradition. Each new technology is not just a better magnifying glass, it is a new kind of key for a door we have only just found. With every laser scan and sky simulation, we gain another chance to sit, virtually, beside the ancient astronomer as they plan their masterpiece. We are not just mapping stones, we are attempting to chart the contours of a lost mind. The promise is that the coming decade may bring revelations as transformative as the pioneering work of the last century, continually sharpening our vision of a genius that chose to write its deepest truths not on parchment, but in sunlight and stone. The true power of these stone machines is not locked in the past, it is an experience waiting for you. You do not need a degree or special tools to feel the connection they engineered. Every year, at sites across the globe, the ancient alignments perform their silent show, and we are still invited to the audience. Stand among the thousands at Stonehenge on a misty summer solstice dawn. There is a palpable hush, a collective breath held as the sky lightens. Then a sliver of gold appears on the horizon, and a precise beam grazes the top of the heel stone, sliding into the center of the stone circle. In that shared moment, the 4,000-year-old calculation is proven once more, not in a textbook, but in the light on your face and the awe in the crowd around you. It transforms from an archaeological fact into a living event. Across the Atlantic, during the spring equinox, the phenomenon is equally dramatic. As the sun sets, the Pyramid of El becomes a stage. The play of light and shadow creates the undulating body of the feathered serpent, descending the northern staircase to meet its stone head at the base. The cheers that ripple through the watching crowd are a modern echo of the ceremonies that once hallowed this exact moment. This is the genius of participatory design. The builders created a spectacle that would renew its wonder for every generation. You are not just learning about an alignment, you are standing completing the circuit between their intention and your perception. It forges a visceral link across time, a direct communication through geometry and light that bypasses language entirely. For those who cannot make the journey, technology now offers a bridge. Detailed online simulations allow you to manipulate virtual models of these sites, toggling the sun's position to see the alignments activate from your own home. Emerging virtual reality experiences promise even deeper immersion, letting you walk a digital Stonehenge at dawn or stand in the chamber as the solstice beam illuminates the darkness. These digital encounters, while different from the chill of a morning wind or the scent of desert air, still make the abstract concept powerfully tangible. They translate the blueprints into experience. Seeking out these moments, whether in person on a sacred plane or through a screen in your living room, does something profound. It changes the story from a historical footnote about ancient people into a personal encounter with a shared human legacy. You become a witness to their success, proof that their machine still works, that their voice, spoken in stone and sunlight, can still be heard. It reminds us that this solar engineering was never meant to be a secret. It was an open invitation to look up, to mark the turning of the world, and to feel, if only for a moment, part of a conversation that began before history was written. But this dialogue with the past carries a profound responsibility. The same sunlight that reveals these alignments also highlights their fragility. A single stone, shifted by erosion, a careless visitor, or the settling earth, can permanently break a perfected over centuries of observation. The very act of rediscovery, through increased tourism and scientific interest, introduces new threats to the delicate balance these monuments have maintained for. The preservation of these sites is no longer just about protecting old stones. It is about safeguarding a precise language of light from being permanently erased. Global organizations like UNESCO designate many of these locations as World Heritage Sites, establishing frameworks for their protection against large-scale development and environmental degradation. Yet the most immediate guardian is often an informed and respectful public. Responsible visitation means understanding that these are not theme park attractions, but fragile instruments. Staying on marked paths, not touching the stones, and following the guidance of site stewards are simple acts that help ensure the solstice sun will find its mark for centuries to come. Beyond physical preservation lies a deeper ethical dimension, one of cultural respect. For many indigenous communities around the world, these sites are not abandoned ruins of a distant past. They are living ancestors, places of continuous spiritual significance. The Hopi, Pueblo, and Navajo nations maintain deep cultural and ceremonial ties to the great houses of Canyon. For the Maori of New Zealand, ancient pa sites and carved meeting houses are woven into their identity and oral histories. To study or visit these places without acknowledging this living connection is to see only half the picture. It risks treating a sacred landscape as merely an archaeological puzzle. True understanding requires engaging with these descendant communities, listening to their oral traditions, and involving them as partners in research and stewardship. Their knowledge, passed down through generations, often holds the key to the why behind the alignment, the cultural meaning that gives the engineering its purpose. This collaborative approach transforms rediscovery from an act of extraction into a respectful dialogue. It acknowledges that the story of these monuments does not belong solely to textbooks, but to the living cultures for whom they remain a vital part of the present. This perspective shifts our entire relationship with the past. We are not simply uncovering lost secrets, we are joining a conversation that has never truly stopped. The stones were built to speak, and descendant communities have been listening in their own ways all along. By approaching these sites with humility and a commitment to preservation, both physical and cultural, we ensure that the conversation continues. We become part of the chain that passes this legacy forward, not as a collection of solved mysteries, but as a living testament to human ingenuity and reverence. The ultimate goal is to ensure that when the sun rises on the next solstice, and the next, and for 1,000 more, it will still find its intended target, and there will still be someone there, ready to witness the light and understand what it means. This shared impulse to build with the sun points toward something far deeper than architectural technique. When we step back from the individual stones and alignments, a more profound pattern comes into view, one that speaks to the very core of what it means to be human. These monuments are not just feats of engineering, they are philosophical statements carved in granite, declarations of a species determined to find its place in the cosmos. The builders possessed a form of genius that defies our modern categories. It was not a narrow technical skill, but a holistic intelligence that seamlessly wove together careful observation of the natural world, a grasp of geometry and number, a profound artistic vision, a deep spiritual yearning, and the immense social will to coordinate a civilization. The pyramid, the stone circle, the mountain temple, these were not separate projects for separate experts. They were unified cultural expressions, where the astronomer, the priest, the artist, and the engineer were often the same person, or spoke with one voice. This challenges a comforting but flawed narrative we often tell ourselves, the story of linear progress, where knowledge accumulates in a straight line from primitive to advanced. These sites stand as monumental proof that a profound, functional understanding of natural cycles, of celestial mechanics, and of the mathematics that govern them was achieved not as a culmination of modern science, but as a foundational act of civilization itself, long before the telescope or the printing press. Their calendar was not a guess, it was a precise, generational project. Their geometry was not accidental, it was intentional and sophisticated. This realization is both humbling and exhilarating. It forces us to expand our definition of intelligence and achievement. It tells us that the human mind, when motivated by a need to comprehend its world, is capable of extraordinary leaps of insight, regardless of the technological tools at hand. More than anything, this legacy reveals a timeless and defining human trait, the desire to reach beyond our immediate, earthly confines. We are a species that looks at the wandering sun and the wheeling stars and feels compelled not just to watch, but to mark, to measure, to participate. We have an innate drive to touch the intangible, to codify the cosmic, to make a lasting testament that whispers, "We were here, and we understood something of the grand design." This is what is written large on the landscape in stone and light. It is a message across, reminding us that our deepest quest has always been to find meaning in the vastness, to build a bridge between the human heart and the silent, majestic order of the universe. Their genius was not compartmentalized into separate fields of study. To truly grasp what they achieved, we must step into a mindset where knowledge was a single, flowing river, not a series of isolated streams. In their world, the science of the sky was inseparable from the practice of farming, the art of healing, the structure of government, and the language of the divine. The monument they built was not merely an observatory, nor solely a temple, nor just a civic center. It was all these things at once, a physical hub where every strand of their understanding came together. This integrated system, what scholars sometimes call traditional science, formed a complete and coherent framework for navigating existence. It answered not only how the world worked, but why it mattered, weaving practical necessity into a tapestry of sacred meaning. When a priest astronomer marked the solstice sunrise, he was activating multiple layers of this system simultaneously. He was setting the agricultural calendar, telling farmers when the season of planting would begin. He was performing a state ritual, demonstrating the ruler's unique connection to the cosmic order that guaranteed stability. He was engaging in a theological act, communing with the sun deity to ensure the renewal of life. He might even have been marking a time for medicinal practices, as herbal lore and concepts of bodily humors were often tied to astrological timing and seasonal shifts. The single beam of light striking the altar was a trigger for an entire civilization's rhythm. It synchronized human activity with the perceived heartbeat of the universe. This is why studying these solar alignments offers us so much more than a chapter in the history of astronomy. We are not just looking at old star charts or primitive calculations. We are glimpsing the very operating system of an ancient culture. The monument was the hardware, the rituals and social structures were the software, and the precise alignments were the executable code. Every stone they placed, every corridor they angled, was a deliberate line in a grand program written in landscape and light. This program had one overarching function: to harmonize human life, in all its facets, with the immutable rhythms they observed in the cosmos. Their success was measured not in peer-reviewed papers, but in bountiful harvests, stable kingdoms, and a profound sense of living in a meaningful, ordered world. Seeing them through this holistic lens fundamentally changes our perception. It elevates the anonymous builders from being mere technicians, skilled laborers moving heavy objects, to becoming philosopher-engineers. They were thinkers who engaged with the deepest questions of existence, order, and humanity's place within the grand scheme, and they expressed their answers not in treatises, but in the most durable medium they knew, stone, aligned with heaven. Their legacy is a testament to a form of knowledge that sought not to conquer nature, but to listen to it and find a way to live gracefully within its cycles. In an age where our own specialized sciences often feel fragmented, their integrated vision offers a quiet, monumental reminder of the power of seeing the world as a connected whole. This integrated vision of the past holds a key to unlocking the future of learning. The field of archaeoastronomy carries a transformative power for education, capable of reshaping how we introduce young minds to both history and science. Too often, ancient cultures are presented in a simplistic timeline, framed as primitive steps on a ladder leading to us. This narrative does them a profound disservice and robs students of a more thrilling truth. These societies were sophisticated observers, meticulous engineers, and brilliant integrative thinkers. By weaving their celestial achievements into the curriculum, we do not just teach about the past, we demonstrate the timeless human drive to understand the cosmos. Suddenly, the abstract principles of geometry become tangible in the perfect Pythagorean triangles of a stone circle. The physics of simple machines, levers, ramps, and rollers comes alive in the epic story of moving a 50-ton megalith. Mathematics is no longer just numbers on a page, but the essential code for predicting a solstice sunrise 1,000 years in advance. This approach makes STEM subjects, science, technology, engineering, and math, immediately relevant and deeply exciting. They are framed not as modern inventions, but as ancient tools used to solve real-world, monumental problems. A student calculating the angle of a pyramid slope is engaging in the same process of applied trigonometry as an Egyptian master builder. This connection fosters a powerful form of interdisciplinary thinking. A single lesson can naturally blend the observational methods of astronomy, the deductive reasoning of archaeology, the cultural insights of anthropology, and the practical applications of engineering. It shows knowledge as a web, not a series of isolated boxes. The most effective way to cement this understanding is through active, hands-on projects. Imagine a classroom where students build simple gnomons from sticks, spending a month charting the sun's shadow at noon to discover the solstices for themselves. Or a group project to construct a scale model of a site-like, carefully aligning a roof box with a light source to simulate the winter solstice beam. These are not just crafts, they are acts of rediscovery, allowing students to physically replicate the methods and experience the triumph of a predicted alignment. This active engagement transforms passive learning into a personal investigation. By highlighting this ancient genius, we accomplish something vital. We inspire a new generation to look at the past not with condescension, but with respect and burning curiosity. We show them that scientific inquiry, monumental collaboration, and the quest to find our place in the universe are not modern inventions. They are deep human traditions, a legacy written in sunlight and stone, waiting for every new mind to rediscover its brilliance and feel the urge to look up and wonder. The final chapter of this story is not written in stone, but in the choices we make today. You can be an active participant in this ongoing rediscovery, transforming from a passive viewer into a modern observer, a citizen scientist of the sky. It begins with something beautifully simple, relearning the rhythm of your own local sky. Mark your calendar for the next solstice or equinox. On those mornings or evenings, find a fixed spot, perhaps a window in your home, a park bench, or a hilltop. Watch where the sun breaks the horizon or dips below it. Take a photo or make a mental note. Return to that exact spot a few weeks later and do it again. You will witness the sun's migration with your own eyes, the same foundational observation that sparked every monument we have explored. This personal connection to the celestial cycle is the first step to understanding the scale of their achievement. Look at the historical landscape around you with a new curiosity. That centuries-old church on the hill, its steeple might be aligned to the sunrise on its patron saint's day. A lonely standing stone in a farmer's field or an ancient burial mound on a local walking trail could hold a forgotten alignment. Research the history of your area, consult local archaeological societies, and visit these places not just as sites, but as potential pieces of a larger puzzle. Ask questions. Why was this building placed here, on this specific orientation? What view did the builders intend to frame? You are starting to think like in blending landscape, history, and sky. Technology now puts powerful tools in your pocket. Smartphone apps can show you the precise azimuth, the compass bearing, of any sunrise or sunset. Others can simulate the night sky as it appeared thousands of years ago, allowing you to test theories about stellar alignments from your backyard. Some even provide augmented reality overlays, showing how the sun would move across the ruins of ancient sites. These digital aids are modern versions of the knotted rope and gnomon, extending your perception and allowing you to experiment with celestial mechanics from anywhere. Your engagement can also take the form of support. Seek out and contribute to legitimate organizations dedicated to archaeological preservation, scientific research, or the protection of sacred indigenous sites. These groups work on the front lines, ensuring these fragile stone machines and the cultural knowledge surrounding them are safeguarded for future generations. By supporting them, you help preserve the very laboratories where this history is being decoded. Ultimately, the most important tool you cultivate is a mindset. It is a blend of wonder and critical thought, of looking up at the night sky with awe while also asking how and why. It is about seeing the past not as a closed book, but as an open invitation. When you stand before an ancient structure and consider its relationship to the sun, you are continuing the most human of traditions. You become a living link in an unbroken chain of observers, a successor to those who first charted the sun's path and dared to build their understanding into the bones of the earth. This journey of rediscovery does not end when the video does. It begins anew with your own curiosity, with your own eyes turned toward the light. Their legacy is a quiet conversation between stone and sky, waiting for us to listen. As we conclude this exploration, we see that rediscovering their solar engineering genius is far more than an academic exercise. It is a reconnection with a foundational chapter of human ingenuity, one written not in ink, but in light and shadow. We have traversed from the misty plains of Stonehenge to the cloud-wrapped peaks of decoding a silent language that speaks of a deep, purposeful harmony with the cosmos. These builders were not primitive people stumbling upon alignments by chance. They were master astronomers, meticulous engineers, and profound visionaries who left a legacy that fundamentally challenges our modern assumptions about the past. Their work stands as a testament to a different kind of innovation, one born not from rapid disruption, but from patient, multi-generational observation and a profound respect for the natural cycles that govern life itself. They teach us that the greatest leaps in understanding often come from looking outward, from seeking to integrate our lives with the larger patterns of the universe, rather than seeking to dominate them. This knowledge invites a renewed sense of wonder for the ancient world, a feeling that these monuments are not dead ruins, but active participants in a story that continues with every sunrise. It also calls for a commitment to preserving their fragile lessons, both the physical stones and the cultural wisdom they embody. If this journey has illuminated new perspectives for you, we would love to hear your thoughts in the comments below. Share which alignment or site resonated with you most. For more deep dives into the hidden layers of our shared human story, be sure to subscribe. Together, let's keep looking up, asking questions, and uncovering the quiet genius etched into the landscape of our world.